Alright, welcome back to the channel. For this video we have a KTM-F, a 25-inch KTM-F Cortec, and this particular chassis is in full vertical collapse. Shoot! Just a thin line across the screen, and normally I just get the chassis given to me and I have to find my own tube, but I didn't have a compatible tube with this one, or I may have, but I don't know what the compatible tubes for this particular KTM-F would be. I've never worked on one of these, so I asked if I could have the entire monitor, so they gave me the entire monitor. So fortunately, for this particular instance in troubleshooting, I'll be able to use the original factory monitor, which is something you always want to have access to for ideal situations. So I have the full original factory tube with the chassis, and it's in full collapse. So let me turn it on and you can see what I'm talking about. Okay, turned right on. You can hear if you listen, just a single high-pitched noise, and there you have it. Just a single horizontal line, complete collapse. And you never want to leave this run very long, you'll burn in the tube. So we'll turn it back off, and we'll get it off the frame, and we'll see if we can't poke around and see what we got going on. The easiest way to do this is to look at your vertical size pot and follow the trace to which wire it goes to, and follow it to where it hooks up to the main chassis, because that's going to be your vertical circuit. The vertical size is going to determine your vertical circuit on the chassis. So we can follow where it goes to the board and follow that trace and see what it goes to determine the IC or a resistor or something on the circuit that's open. And we'll see if we can't figure it out. So here we go. Alright, so here we have the chassis removed from the tube, and I was told that this was in vertical collapse prior to any work being done to it. The person that gave me this, or I guess the owner, went ahead and did a cap kit, but it didn't make any difference. So we had the vertical collapse before and after the cap kit. So the best way to do this, to find out, let's see, there is, there's an IC here, there's an IC here, there's an IC here, there is an IC right here, there's an IC right here. So the easiest way to determine which one of these is the vertical IC is to follow the vertical size. So if we look at our adjustment pot here, vertical size is this guy here. It's vertical position, vertical size. So vertical size is the second pot, which is, oh, I gotta take this out of here. Son of a bitch. Hey, well, I said son of a bitch prematurely. Okay, so we got the second pot is vertical size. So if we turn it around, these two here are going to be in series, or together on the same pad, and it goes to the blue wire. It looks like 1, 2, 3, 4, 5. Yes, the blue wire. The other one's going to be the ground, the common ground, which goes to, it looks like this wire here, which is the common ground. So if we go 1, 2, 3, 4, 5, which is the blue wire, and going off of this, the blue wire is the fifth one, 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5 from the inboard, which in turn will go to, zoom in. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, it's going to be this one right here. How did I get my stupid thing all bent up here? Let's fix that real quick. Okay. 1, 2, 3, 4, 5. So we follow this trace. It goes to right here, R210, which jumpers over and goes right to IC201. So I can say with 100% certainty, IC201 is our vertical, vertical IC. But it looks like this area gets a lot of heat. See, this area gets a lot of heat, it looks like, from the discoloration you can tell. And it looks like somebody's already done some reflow work. I have not done anything to this chassis, so it looks like someone has done some reflow work here. So either they already replaced the IC, which I probably suspect they did, or they at least reflowed it. They didn't clean up any of their flux or anything, so I don't know if they replaced it or reflowed it, but I'm suspect of the IC201. So we'll also give this, it looks like there's a lot of other reflow work that's been done. The flyback is original. You can tell because it still has the glue on the pots. So the only thing that's been done to this is possibly a reflow and a cap kit. So let's zoom back out here and see if we can notice anything right off the bat. Give me a moment here. I haven't even given this a look over yet. Let's see. I don't see any cracks. And right off of the bat, I don't see anything that leaps out at me as having cracked or broken solder. It looks like someone's done some reflow on the header pins here. And also here on the video header pins, but that won't cause horizontal collapse. I mean, I'm not skeptical of the work that's been done to this, because this is the same lot of chassis that I have been working on, and the same owner, and he does a good job with the solder work, so I'm not suspect of that. There's another area here by R415 that looks like it's discolored from heat. Maybe you can kind of tell that. Somewhat discolored from heat. Oh, now that I look at this through the camera, yeah, this is one of these tall ceramic resistors, and it is loose. That's why, see, this one has glue on it. They put glue on it. Even this one's loose, but they put glue on these to keep them moving, because if you bump it, you can break the trace or break the pad. See, these have glue on them too, but they've been removed. All of these are loose. So now I'm suspect of all of these resistors. Let's check this one. This one hasn't been reflowed, but it's also not loose. These two here are this one. Well, that seems okay, and this one. That seems all right. I don't see the solder pads moving. Let's go back to this one here. This R415. Oh, I don't see the solder pad moving, but it looks like the trace is broken. Can we see that? Can you see that there? Oh. It looks like the trace is broken right here. We can get out the meter and check continuity, but it looks like it's broken. I don't know what R415 would deal with, because it's so far away from the vertical circuit. The vertical circuit's all right here, I imagine, and R415's way... Where's it at? It's up here, way up here. They have it glued to this inductor, but apparently it's not enough. Well, let's get the meter and see if that is indeed broken. It appears to be. Maybe we can get lucky. Okay, we got our meter here. It's on continuity mode. Leads are good. Let's test that trace. Okay, can I get this in frame here? Possibly. So it looks like, if we look here, this pad here follows the trace over to right here, and it's open. Look at that. If we go here to here, it's good. If we go here to here, that's open. What if I touch the... Nope. Oh. So that's that side of the pad. Maybe it was broken, and I shoved it back together with the lead here. Oh, see, now it's open again. Oh, yep. See, now it's open again. Huh. Well, maybe we can get lucky. I don't like these stupid chassis that have these tall resistors, because this very thing can happen. I don't know if this, but with this having this problem prior to any work being done to it, I don't know. Well, I say prior to any work done being done by the person that I got this from. It's possible somebody else was trying to troubleshoot this in the past. What the hell is this? It's possible someone was trying to troubleshoot this in the past and they did all that, but look at this. This is definitely jury. Look at what the hell is this? What is this? Oh, that's just a piece. Oh, okay. I thought someone had shoved a safety, oh, look, look at that. They shoved something down in there because I just pulled it out, and look what's going to happen. Holy shit. Look at that. Someone's got this all messed up here. They've got the wrong oh, shit. You got the wrong ferrite coil in here. Got it. Look at that. Maybe I can make that work again. I don't know. So I'll see if I can work some magic on that. That's quite an interesting fix they got going on there. I've got a K7000 coil. I may just try to put that K7000 coil in here. It's a different footprint, but all it is a coil. You only need two conductors. Unless this uses 3. I'll figure it out. But let's fix one thing at a time here. And let's see if we can patch this. And maybe this was the problem. I can't say. We'll test it one more time. We got our leads here. Let's test here to here. Good. Here to here. Not good. And you can clearly see it's one trace from this point to here. And here to here is good. Here to here is not. Okay, let's turn on the soldering iron. I still don't. My replacement fiberglass pins won't be here till tomorrow, and this is the fifth different seller advertising these fiberglass scratch pins as being an actual fiberglass scratch pin. So far, 4 for 4 have been fiber pins and not fiberglass pins, and those don't do jack shit on this. So hopefully the ones I get tomorrow will work. But in the meantime, I can just scrape some of this away here. The old-fashioned way. Where's my brush? There we go. So now we have the trace exposed. Did I lose you in the camera? No, it's right there. So there's my exposed trace. And we're just going to solder to it. I got to turn my fan on. I don't want to breathe in the lead. And here we go. Let's see what happens here. There you go, just like that. So any bets on whether it has continuity now? We go to here, and we go, leads are still good here. We go to here and here. Well, what do you know? It's a miracle, amazing. Well, that was a quick and easy find. I don't know if we want to kind of waste any time doing any more troubleshooting, because I'm sure the vertical IC is still shot. I doubt that this repair will really do anything. I'm assuming the vertical IC is still bad, but you never know. We'll cross our fingers. Maybe we'll get lucky. Let's see, I gotta put this in here. Can I make this easy? Yeah, somewhat. Alright, let's clean up a bit here. Throw our iron cable that way. Alright, let's get this on the tube and we'll test it one more time. Okay, I'll hook back up, ready to go. I don't have a video signal, we're just checking to see if it's still in collapse or not. We can check that by just turning up the flyback. So let's get the camera on the old pot of try. And let's see what happens. Here we go. It's not making a high-pitched noise anymore, but that's probably because there's no video hooked up. Just a dark screen. Let's turn our flyback up. Oh, no. Damn. Well, not completely unexpected, because that open resistor shouldn't have anything to do with the vertical circuit. Is that going out of focus? Yeah. But it's possible that that resistor opening up could have caused some damage, so it doesn't stay focused. Anyway. Okay, well, back to the drawing board. I'll have to do some ring out and some testing, and hopefully we'll see if we can't figure out what's going on. So let's see what I can figure out. Gosh dang, that's it just won't stay focused. Oh well. Alright, hang on one second. Well, we're back on the bench here, obviously, and let's take a minute to review before we kind of go anywhere. Normally when you have vertical collapse, you want to eliminate the most likely scenario first. In this case, I double checked the yoke to make sure that the vertical winding wasn't open like it was on that G07 I recently worked on. We have a 5.3 on the vertical, which it's, you know, I'm used to seeing it around 10, but maybe for this Cortec that's normal, I can't say. But it's not shorted and it's not open, so I'm not really worried about the yoke. The yoke is good. Next, you'd want to verify that your pots aren't broken. Your vertical size, vertical position, vertical hold, they are not broken on this. They are in good condition, and you want to ohm them out to make sure they work, and they do. Then you want to make sure you have continuity from your connector here on the remote board all the way to your chassis, assuming that these are remote mounted. If they're not, you can just check them on the actual PCB. But that's all good from point to point, and all of the solder joints and the header pins on the connector here are good. We can look at that and verify that those are good. Yes, they are. No problem there. I already looked at them, but they look okay. So, it's actually been a couple of days. And in the meantime, I have ordered some new vertical ICs. Now you can see here that this is quite obviously the vertical IC, this guy right here. And if we zoom in, you can see that it is part number DBL2054D. Now those aren't available anymore. They cross-reference to TDA1675 alpha. So what we're going to do here is this doesn't check bad. When I say doesn't check bad, I mean there's no pins shorted to ground that shouldn't be shorted to ground. There's only one ground pin to here, and it checks good. The rest of them don't read to ground, so it's not shorted, but it still could be bad. I don't have any schematics for this. I'm too lazy to look them up. So, like I say, I'm not a like it says, I'm not a professional. This is amateur hour. So, I'm just going to shotgun this in and see what we get. I also have this chip here is part of the video circuit as well. It's the cross reference is for a Phillips chip, and it has to do with deflection as well, I believe, from what I was able to research. So I have these on the way. They'll be here in a couple of days. I also ordered this chip just for shits and grins. I got them right here, but it's not part of the vertical deflection circuit or any other part of deflection circuit. I went ahead and ordered these just so I can have some. It's a TDA2595, and you can see here TDA2595. So I actually ordered a couple of these just so I can have these on hand as well. But just so we can rule out the vertical IC chip as being the possible culprit, I'll go ahead and install it in here, and then we'll see what we get. So let's do that. Okay, zoom back out. Let that heat up. While that's heating up, I should have already had it running. I have not reflowed the header pins, but none of them are cracked. They're all in decent shape. I don't see any that are cracked or broken, or but there's no sense in not reflowing them. It looks like someone's already reflowed that one, which I think might have been me. I forget, it's been a couple of days. But someone has definitely either already replaced this vertical IC or tried to reflow it, because this has definitely been reworked. But it is the original one, so we're going to put a new one in and see what we get after I do some reflow here on the header pins. If this works, if it works after this, I'm going to say that this was the issue. Why aren't you focused here? If this works after replacing this, I'm going to say that this was the issue, because this is all actually good. I don't see anything cracked or broken, but we're going to reflow it anyway, and if it works, we'll blame the vertical IC. So let's do some quick reflow here. Okay, that was nice and easy. Nothing's touching. Okay, while we're waiting for the desoldering station to warm up, let's do another quick look over here of anything that might be suspect. I just don't see anything right out of the gate here that would be like, oh, we got a broken solder pad kind of thing. So from what I was told, this was working just fine one day and then just collapsed. So you would think that it's a cold or broken solder joint, but I simply don't see any. This broken resistor was the only one that I could find, the only anomalous pad or whatnot, what have you, that I could find. But it didn't have anything to do with the vertical circuit that I could trace out. Alright, just wanted to do that real quick. Don't see anything else. Okay, well, fun times ahead here. Really? Hang on, guys. I got to clean out my desoldering gun. It's got too much solder in it and it's not performing very well, so give me a moment here. Okay, it should be good now. Oh yeah, I can hear it already. Yep. Outstanding. Alright, let's inspect this to make sure everything is free. Well, I can already say that one's not. Okay. Well, you know what? So sorry, guys. There you go. Sorry. It's hard to, you know, I zoom in for this and I move it around, and it's hard to watch what I'm doing and look up at the camera at the same time. So I'm sorry about that. But everything appears to be good. So let's go back. Let's go back out. Let's grab a driver and we'll take that out. Alright. I don't have the right size of Phillips head, so we're going to have to use a flat head here. Really? There we go. Huh. I guess I could have used a number 2 after all. I didn't know. Alright. Everyone can use a good number 2. Now will it just come out nice and easy? If we did our job correctly? There you go. Awesome. Alright. Let's clean up our pads and then give them a good inspection. Where'd you go? Here it is. Okay. Okay. Doesn't look too bad. Yeah, except for this one here on the end where some of the pad's gone, but not too bad. It all looks okay. We can check our continuity real quick. That won't be a problem. This goes to here, this went to there, this goes to there, this goes to there, nothing there. This one goes to here, this one goes to there, this goes to here, this goes to there. That's the ground. There's that. This goes to there, and this goes to here. Alright. This is the only one here I don't think has a trace or anything to it, so I think we're good to put the new one in and cross our fingers. I'm doubtful, but at least it's one thing else to eliminate as a possible problem. TDA 1675 alpha. It actually says that on there. Look at that. It actually says right there. TDA 1675. So that makes me wonder if somebody put the wrong type of vertical IC in. Huh. Interesting. Well, maybe not, maybe so. Maybe we'll get lucky. But I doubt it. It's never that easy. In my experience, it's almost never the vertical IC. It's always either a resistor, a capacitor, or diode, or something else in the circuit. This other chip right here is part of it as well, this guy right there. but I have to wait on those. Those are coming from China. They won't be here for who knows how long, a couple of weeks. So hopefully this fixes it. If not, then we're gonna have to wait a while. I will, you won't. And this is never easy. Come on. A little persuasion. Man, this is tough. All right. With this heat sink here, it's not making life easy. Well, it's all lined up, it just won't slide down in there. Ah, oh, damn it. There we go. Okay. Alright, now where'd my screw go? There it is. Oh. Okay, let's see if we can push those back down. Okay, all installed. Looks good. Let's turn this around. Zoom in here. And let's get this puppy soldered in and fired up and cross our fingers. Like I say, I'm skeptical because obviously somebody already changed this out. It's quite apparent now that someone did because they didn't put the right part number back in, but it's possible that this failed, they put the wrong part in, and the correct one will fix it. I doubt it, but let's find out together. Alright, let's clean it up again. Looks pretty good, I must say. That looks pretty darn good. Alright. Let's get it hooked back up, see what happens. Alright, so here we are again. I got everything ready to go. We got anode, neck, yoke, ground. No video because I just want to see if it's not in collapse anymore. And our remote board. So it's all hooked up, ready to go. Join in the knowledge with me, if you will, of whether or not this was the problem. So let's see. I may have to turn off the light so it doesn't lose focus on us. But let's just see what happens. Do we get lucky? I doubt it, but we'll find out here. Oh, got high voltage. That's always a good sign. Do we get lucky? We do! Ha ha!
I am the smartest man alive!
Look at that! Outstanding! Oh my god, that's not good though. It's been in collapse for so long that got the line burned across the middle. But that's what happens. Hot diggity! Alright! Sorry if that clap was loud. Hey, you get lucky every once in a while. So before it dies, let's turn it off, give it a video signal, and see if we can adjust it and make it look good. So let's turn off that. Let's plug in our video. Okay, red, green, blue. And I got a jumper here for the sink. Hot dog. Are we still focused up here? We are. Let's turn this. Is that decent? Okay, so let's turn off this light here so we can get a better look at how the image is. Hello. All right, so oh, it's got that high-pitched noise again. Wow, that's not good. Let's turn this off. Let's turn our brightness. Contrast is down, brightness is down, screen pot is down. And let's see what that does. It's still making the high-pitched noise. Let's turn up our flyback until we get our raster lines, if we can. Okay, that's maximum. Vertical hold. Is H hold on here? Something's not right. Something's not good. So let's turn our flyback back down. Let's see there. Brightness, contrast. Okay, so we got a hold issue. Horizontal hold. Vertical hold. So we're good on that. Vertical position. H size. Vertical size. So everything's working, but the image is upside down. The image is upside down because the yoke has two different connectors we can hook up to. So let's hook up to the other one. Turn my light back on. Okay, now the image should be right side up. But let me double check to make sure I got my sink hooked up properly. It looks like I do. Let's try. Do I have to jumper the sink? I don't know. Let's find out together here. Let's turn this back off. Well, the high-pitched noise is gone. I put the sink on the other pin for the, I believe, vertical sink. Yeah, see, that was definitely wrong because now I don't have an image. So let me put the sink back on the other pin. Huh. Well, that's the right pin. I don't think it needs to be jumpered. So that right there is definitely where it needs to be. And this is supposedly a standard res monitor. So our holds are dialed in. It's not a hold problem because we have a stable image. It's just kind of doubled and messed up. So, well, looks like further troubleshooting is required. Stand by. Well, I got it fixed. I'll show it off here in a moment, but it turns out it was not a problem with the chassis. It was a problem with my research. I was told that this monitor came out of an Ivan Stewart's Super Off-Road. But I don't see how that's possible unless somebody stuck this monitor in that cabinet because the original monitor died and wasn't aware that this monitor is actually a medium res monitor. So it's been a number of days and I haven't gone back and reviewed my footage from earlier in the series here of this repair. But you can see here that this is actually a KTM-F. It's a Cortec or Sharp Image, whichever you want to refer to it as, KTM-F. And in doing some research, I quickly found out that this is actually a medium res chassis and medium res monitor. So I don't know why it was given to me and told that it was out of an Ivan Stewart Super Off-Road. It may have been. Someone may have stuck this in there trying to get the game up and going, but this is a medium res monitor. And I can show you here that actually, we saw before the image had a split screen, and that was very indicative when I saw that of a resolution problem. That's why I thought it was an issue with the sync. But I tried every combination of sync and I couldn't get it to work, and I went and looked it up on the internet, and sure enough, it's a medium res monitor. So I got the test pattern generator hooked up, and you can see here that it's set to medium resolution. I got a little jumper there for my connector going over to pin number 6, and as you can see, it is working. So let me get it on the tripod here and I'll go through all the tests and the settings. Let's do red, green, blue. Little degaussing, not a big deal. And let's see, it's too bright. We need to adjust our brightness for our white balance here. Right about there is where we want it. Contrast, I'll say, let's get out of this screen. There's our convergence. Convergence looks decent. Let's turn our contrast down a bit though. I'll say roughly there. Let's do our vertical position. Of course, all these settings are going to be different when you put an actual game on, because the test pattern generator kind of overdrives the signals. So if you set your brightness and contrast and everything per the test pattern generator signal, when you hook it up to a real board, it's going to be much darker. So I'm not really going to be too worried about that. But let's see if we can adjust our position and size to kind of at least fill the screen. Vertical position is this guy. Vertical size. The linearity is kind of, linearity isn't too good, but I don't know if there's an adjustment for the linearity. Maybe there is. Let me see here. There's an adjustment pot right here. Let's see if that's the linearity pot. That's an additional size pot, so not sure. Not really going to worry about it because it still looks pretty good. I say that's not too bad. Let's continue on here. There's our checkerboard pattern. Color bars. Yeah, I say it's good. So, lesson learned. The KTM-F is a medium res monitor, and it had that bad resistor, or the resistor with the broken trace, which probably caused who knows what kind of damage. And somebody put the wrong, it's possible, it's quite possible that that resistor being broken took out the vertical IC. I can't say, it doesn't appear to be part of the circuit, but I couldn't find any schematics on this, and I'll admit I didn't look very hard, because I like to try and figure this out on my own, and then if I get to a brick wall and beat my head, then I'll try and look up schematics, but I like to try and figure this out on my own with my own ingenuity and stuff like that. So it's possible that that resistor having that broken trace took out the vertical IC and someone replaced it with the wrong kind, or they replaced it with the working one, but because that resistor was still bad on the trace, it took that one out as well. So I think we fixed that resistor pad and put a working vertical IC in there, and we got it working. So that's about it. If you ever come across one of these and they have this problem, hopefully you can look for the same thing. And I appreciate everybody watching. Like, share, and subscribe if you'd like. And I thank you very much. Well, it turns out the excitement doesn't end there. There is a convoluted history with this chassis, and I wasn't aware of it. There's actually two different versions. There's a standard res and a medium res. I had just figured that there was a medium res only. But what made no sense to me was the fact that this was advertised to me as a standard res. It came out of a standard res game. I think someone got confused just like I did, because when I did the research and looked up the KTM-F on the front of here, everything I found came up with standard resolution. Well, it turns out that the KTM-F is not the identifier of the chassis. there are two versions, a standard res and a medium res, and this KTM-F sticker is on the front of both of them. So the engineers kind of screwed you over on that. The KTM-F is not the identifier. It turns out that there's supposed to be a secondary sticker somewhere on here, identifier, that labels this as an SI-325, or I'm sorry, more specifically an SI-325, or an SI-325MR for medium resolution. And it turns out that's what this is. This is an SI-325MR. And the only way we found that out was by hooking up a signal to it and verifying that it was medium resolution. But the standard resolution version is just SI-325. Now, there is a thread on the Killer List of Video Games forums, or KLOV if you will, that someone was kind enough to already have to go through this headache and chronicle the differences and all the information regarding these two different versions. And they go by the name of Interlock, and I will link the thread in the description below. I think you might have to be a member to view pictures, but you still should be able to view the thread and read what it says. But basically, they chronicled the differences, and the main difference is that on the standard resolution, in capacitor location C909, there is no capacitor. Well, I take that back, actually. Hang on, I may have that backwards. I don't want to tell you the wrong information. I got to pull it up here. I can't remember. So, okay, so I take that back. On the standard resolution version of this chassis, C909 location is an empty hole. And D903 is also not populated, and there's a jumper going across the inputs. So that is the main visual difference, and on the medium resolution, C909 and D903 are populated. So if you took these, the standard res and the medium res, and put them side by side, except for that capacitor and that diode, they are visually and completely and totally, utterly identical. There are other caps that I think may have different values, but for the most part, that's the only real main difference. So, so you can understand my confusion given that information, because visually there's no real way to know except for that capacitor and that diode. Now, if you didn't know that, the only way you'd be able to tell is by hooking it up and giving it a video signal. Now, that also gives another problem, is because let's say you just get one of these chassis by itself with no monitor. Knowing that information of the C909 and D903, that helps you out, but if you didn't know that, you wouldn't know whether you had the standard or the medium res version if you didn't have the sticker, if it was peeled off or couldn't find it. And you would have to take a gamble of whether you had the correct yoke or not for your medium or standard res. So fortunately, this is the original tube that came with this chassis, so it all works out for me and the original owner of this. But this is just a giant learning experience for me, and I think probably for you guys, because I've never worked on one of these. I had absolutely no idea that this was two different versions of the same chassis, SI-325 and SI-325MR. I looked high and low, and I could not find any identifiers except for the KTM-F, and that's where I fell into the rabbit hole, because that's on both. It's on the standard and medium res, and there's no way to know. And fortunately, I found the thread that I linked down in the video description, so you can read up on it yourself as well. But I wanted to put that out because I think I didn't want to give out misleading information, because there is a standard res version of this chassis. If someone got a hold of one of these and they thought it was medium res, I didn't want to run anybody astray or lead them down the wrong path, because I don't like to do that. Obviously, no one wants to do that. So I wanted to make the clarification here at the end of the video that there are two different versions, and you can tell by the C909 and D903 locations if there are components in those locations, it's medium res. If there are no components in those locations, it's a standard res. That's the real main way you can tell the difference. Otherwise, unless you can see the sticker on the side somewhere, there's no way for you to know. Like I said, they're both labeled KTM-F, and it's that's just stupid. But anyway, thanks again. I wanted to clarify this at the end so we don't lead anybody astray and everybody understands. So again, thanks for watching, and we'll see you next time, and I appreciate you viewing.